All right, welcome to the first video for the arcade game, one of two in the 2020 Holiday Hack Challenge. This one involves JavaScript and moving a character around a map to avoid different obstacles, and you have to program that character using JavaScript. So it's more of a programming challenge than it is a game, but it is pretty fun to do. It does take a while, so I'm going to be referencing my notes and trying to keep it brief because otherwise this video could get pretty long if I step by step walk through each of the challenges. But I'll try my best to keep a balance between explaining it enough and being brief enough so that it's not way too long to follow along. So let's hop over to the game here. I think we get some hints. This is with my second account, just to get the experience of showing how the hints come out and the achievements get unlocked. But yeah, it looks like they do give us some hints here. So I'll talk about loops, filtering items, enumerating objects keys, minifying code, push array items to the beginning of an array. So all sorts of that fun stuff. We're not going to go through those hints, but it even gives you some more hints here. JavaScript in 14 minutes. So yeah, if you're watching this video, you should definitely know at least a little bit of basic JavaScript. It would just be too long to explain the concept of programming and then even JavaScript on top of that. So hopefully you have a basic level, starting with the stock, probably a good idea to understand even the solution for this. But the whole, I guess, premise for the game is you've got these characters called munchkins that have nabbed all the lollipops. Use JavaScript to retrieve the lollipops from all entrances of CrinkleCon. So this is like a multi-step game where the levels just get harder and harder as you continue through the game. So you can either, if you quit, I think it saves somewhat of your progress, which is nice because this is kind of a long challenge, or start at entrance number 1, which we will do. All right. So there's actually quite a decent bit of documentation to take in first time you're going through this. And I, again, will try to keep it brief, but basically you have your elf character, and you are navigating your way through this almost like chess-like structure world, and you're trying to avoid getting hit by Munchkin, one of the characters here, avoid falling into traps. You can't move where there's certain obstacles like these, and then you need to make sure that you collect all the lollipops before you head to the exit. And as the game goes on, they start to impose restrictions based on the number of lines of code you can have, and different sorts of things you can and can't do with JavaScript. So here we've got different objects. The elf, that's you. The yeeter, this is something that, if not, or can be triggered by levers. Same thing with pits. You can actually close pits off with levers. Those need to be programmed. Lollipops, you need to collect those as you go through. Munchkins you want to avoid. I think if you do run into them though, they give you some sort of challenge that you have to solve. Otherwise you lose the round. But yeah, the overall end goal of this is to get all the lollipops and go to the end goal. You will have to restart if caught by a munchkin without first solving their JavaScript challenge properly. And those are dynamic, and you have to have code to solve those challenges that they give you. You don't want to stand in the same square when telling them an answer. Instead, you must be within a 1 grid square in any direction, including diagonal. So we want to make sure we avoid moving onto that direct square where a munchkin is. Additionally, the spring traps, also known as yeeters, are set all over the map. Don't go on top of those. Pits are also dangerous if the bridge is down. This is a down bridge. This is a bridge that is not down, that is up. So you can walk across that. You can also have munchkins fall into those if you open them. There are obstacles, such as, I think this is a barrel and these are rocks. We can't go into that square if that's the case. I'm trying not to sneeze. There are levers that can be turned. So this is a lever that's able to be turned off. Again, we have to call this function only after we properly submit the answer to whatever question it is, and we do get to know beforehand. Okay. Yep, so these are the challenges I was talking about. Both levers and munchkins have these challenges, so when you try to interact with them in some way, you have to solve the challenge using JavaScript code before you can succeed in either avoiding the munchkin or turning the lever. Current level objects window, you can see the details, so what type of question you're going to be asked, stuff like that. And we've got a console window for JavaScript output, and we're the ability, obviously, to run our code. So here we are in the first level. We can see that it's going to move us left 1 if we run that. And we fail because we did not solve both of the objectives, one being collecting all the lollipops, which is just 1 for this level, and 2, getting to this green circle, which is the exit for the map. So it says here, program the elf to the end goal, no more than 2 lines of code and no more than 2 elf commands. Okay. So if we click on these, we get all sorts of details. There's a lot of documentation to read for each. I suggest, before even really watching this video, if you're stuck, make sure you go through and really read all these well. So here with the elf, we've got basically a API definition for what we can do with the elf: move up, down, left, right. Move to, we can move to a specific object in the game. This could potentially be they does some sort of simple path finding. This could potentially save some calls, because at some point we're already restricted to the amount of calls we can make regarding movements. So get lever, get the data required, pull lever. Basically the same type of challenge. Ask the munch for the challenge, tell munchkin the answer. Okay, so this is showing moving to lollipop, moving up, moving to, so moving to directly to different objects. All right. So, you can click on all these and read through them. Can move towards this object using elf.move2. So actually, we're going to use that. We could just use a move left, but let's be fancy and use the move 2. 0 is the desired lollipop number. As we can see, the only one here is 0. So we can do that. And then we need to not only, let's just run it. So it'll get there, but it'll still fail because our elf has not moved to the green circle. So we'll try again and move up. And I think if you do, if you're trying to move somewhere and you do more than that value, it's still accepted. So for example, I don't want to count these how many squares to get there, so I'll just do 50, and that won't count against me or anything like that. All right, so we're moving up after we get to lollipop, and this should solve this level. Boom. Okay, so trigger the eater. To move the lever, elf.getLever, and then the lever number. Manipulate the resulting data however it asks and send the answer to pull lever. Now if the answer is right, the eater will release and you can move freely. All right, so let's click on this lever to see how we solve this, or what it expects. So add 2 to the return numeric value of running the function elf.getLever. For example, if you wanted to multiply the value by 3 and store to a variable, you could do this. Oops, okay, come on. And submit the sum by using pull lever. In order to run pull lever, you must be standing in its grid square. You must specify the lever number when using elf.getLever. Okay, so we need to add 2 to the return numeric value. So that is easy enough. So the first thing we want to do, go to the lever. Next thing, run get lever and store that value that is returned. And then we need to add 2 to that value and call pull lever with that updated value where we're adding 2 and getting the sum of that value. All right, so we're going to do is it move to or is it move to lever? Move to. Oh, I see. Move to lever at 0. Okay. So we're going to move to the lever. We could also have just done move left, the proper amount of squares. And then we want to do var. I can't do that. Oh, X. I don't know why I'm thinking about this. And then we want to call elf.pull underscore lever. And we need to specify the lever number, which is right here, 0, also right here. Okay, so that calling that function is going to return the value that we need to add 2 to. Okay, and then we're going to do elf, excuse me. It's elf get lever and then elf pull lever. Okay, and we want to do x plus 2. So what we're doing is we are providing our answer and then pulling the lever, and if we're right, that yeeter spring will go off and basically deactivate, allow us to pass. If we're wrong, we'll fail the level. Okay, so we can just run that and see if it works. We'll have to do more stuff, but make sure that works. So we got correct output, so that's good, and then we also got we saw visually that the yeeter spring deactivated. So now we're able to walk through it, whereas before we were not able to. All right, so after we pull that lever, we're standing here. We want to get to this lollipop and then go straight up. So we need to move 1, 2, 3, 4, or we could either do move left or move to lollipop at 0. Elf.move up, and we'll do that little trick where we don't care to count. And let's see what we get. Okay, so I think this has something to do with the pathfinding. See, our little elf is pointing upwards as if they were trying to go into this obstacle, which is why this failed. I know sometimes, or in the past, I've read that the pathfinding isn't great. It'll try to avoid stuff like this, and when it can't, the whole thing fails. So let's just try move left instead of the pathfinding. So we're going to want to move 1, 2, 3, 4 spaces left, and let's try that again. You got to be careful with the pathfinding is what I found out. Yeah, that was it. So if you have weird behavior when you're using move to, just keep that in mind. All right, you win. Now we want to pick up all the lollipops. Okay, so this is saying program the elf to the end goal in no more than 4 lines of code and no more than 4 elf command function execution statements. Okay, so yeah, let's use move to. So I think we should just be able to do, since there's no obstacles in the way, I'm not really worried about using the pathfinding. And we'll end up here, so then we just want to move up, really just 1. And let's see if that works. All right, so we get the first lollipop. We're going for the second one. All right, and then the last one. And then we move up, and we win. Okay. Continuing. Up, down, loopiness. So this is where it starts to get a little bit difficult. So using another for loop could reduce how many, okay, that's a good hint, how many elf function statements are used if we use a for loop rather than printing out, elf.move whatever, however many times. Because it is putting those restrictions on how many elf calls we can make. But a for loop, you're only writing it once, so you're kind of bypassing that restriction. Using elf.move left 40, so yeah, we'll move your elf as far as possible before hitting an obstacle or the end of the screen. So this is what I was saying with the move up 50 ordeal. Okay, so we seem to want to go up, then left, or really left, up, left, down, left, up, left, down, left, up. Okay, so even just saying that out loud, I'm already detecting a sort of pattern. Now we know we can use that maximum left or maximum move value trick so we don't have to calculate the exact movements that we need to make. So like that left 40, up 50 type ordeal. And this will be helpful because there is a pattern here, but it's not all the exact same moves. Here, if we really wanted, or we had to calculate out exactly step by step, we would have to do left 1, up, whatever this is, left 2. So it all wouldn't be uniform. But we can use that little tip of maximizing the move, and it'll just avoid, it'll stop when it sees an obstacle. So it's kind of dynamically determining that how much it needs to move for us when it sees an obstacle or the edge of the map. So we have no more than 7 lines of code and no more than 6 elf command statements. So if we try to do move left, that's 1, move up, that's 2, move left, that's 3, down 4, left 5, up 6, left 7, down, we'd already be out. So we're gonna have to use some sort of a for loop or other trick to minimize the amount of elf statements that we write. So for this, we've already kind of determined that there is some sort of a pattern. It goes left, up, left, down, left, up, left, down. So we can leverage that. So the way we are going to do this is write a for loop in JavaScript, and that looks like a for loop in really any other programming language for the most part. So we're going to set our initial value, and we need to do this 2 times. So we'll do I is less than 3, I plus plus, and if you do notice me looking over my other screen here, it is because I'm referencing my notes just to make sure this video doesn't last forever. But we know that our pattern is elf.move up. We could just do, move left. 10 doesn't matter. Move up. 50 again doesn't matter. It'll stop when it hits or finds the obstacle. Left. And then down. Down. So it's going to go left, up, left, down, and then it'll repeat the next iteration of the loop, left, up, left, down, and that'll be twice. So far we've used 1, 2, 3, 4 elf statements, elf calls, and we have, 6? So let's do elf dot, oops, where's my code? Oh. Okay, so we're running into, we can't have more than 7 lines of code here. Left, up, left, down, left, up, left, down, left, up. Okay, so I'm remembering from when I first solved this. 1, 2, 3. 1, 2, 1, 2. Okay, so here's what we're gonna do. Starts at 0. Okay, so this is actually gonna run 1 time, 2 times, 3 times. Yes, and there was a reason for that. So we don't actually want this at 10. What we're going to do is set this to 3. And that is because that is the length from, I'm pointing at my screen like you can see that, point from here to here. So this is going to be 1, 2, 3 moves. If we did 10, we'd go all the way here. So we've got the first iteration, left, up, left, down. Second, left, up, left, down. Third, we're going to do 1, 2, 3, and then up. And yes, there's technically still more code to execute, but it's going to hit that green circle, and then the game's game's going to be won, and it doesn't care about the rest of that code. Is something that I had just found out trial and error. So let's just run this and see what happens. So as you can see, we avoided that obstacle, even though we specified a move further than that. And when I was actually going through this originally, I wish there was like some sort of like fast forward, because you'll see as we get towards the last few levels, it gets really annoying just watching this guy, especially when like you get to the last step and your code fails. It just gets like, you're just sitting there like, oh my gosh, I need to run this again. All right, so that's it. We won. So basically, like I said, it was, we were hitting those edge cases with how much it can move left to hit that last lollipop. We didn't want to go one more, because otherwise when we went in our loop to go up, we would have hit this block instead of this circle, and we would have lost. So we're kind of, leveraging the intricacies of how the game interprets our code. Additionally, we brought in the for loop, and that saved us calls to elf, because we had a restriction of only 6. And so you'll see as we go to the other levels, we're gonna have to start playing with those tricks with JavaScript. All right, so here it says experiment with elf.moveTo function. You might be able to get 2 and 1 if you move to Munchkin 0. Okay, so now we, just like the levers, we can click on the munchkins to see what sort of answer they're looking for. And just like we did get lever, we'll have to do, I think it's like ask munchkin or something. Yeah, ask_munch. Okay. Again, we can do that simple path finding. This is basically the same type of challenge. Yeah, so we do not want to run into them. We have to stop within one block of them before doing the ask munch. Okay, so it looks like we need to move up, grab this one, grab that one, and we can, immediately after grabbing this one, we can do the ask munch. Yes. So let's see, what is the munchkin looking for? We need to go to current level objects. I will send you an array of numbers and strings. Return an array that contains only numbers from the array I give you. Okay, so we need to ask munch. We'll get this array as a stored in a variable, and then return that with only numbers. All right, so the first thing we need to do is move towards lollipop 1, and then we want to move to lollipop 0. It's kind of hard to see, but it says 0 there. And then, since we are within 1 square, we want to do ask_munch. Their number is 0, and store this in a variable. And our restrictions are no more than 10 lines of code and 5 elf commands. Okay. Okay, so this is the part where we give it the answer that we have. So for this, we can use a JavaScript filter. All right, Mozilla usually has some good JavaScript docs. So this creates a new array with all the elements that pass the test that is implemented by the provided function. Okay, and so we're providing it, or we are running a filter on an array variable, and then providing it a function that only the values in that array that pass that function's test actually get outputted. And that's what we would give the Munchkin. And the test that we need to run is this a number? And if it's not, then we shouldn't give it to the Munchkin. If it is, then we need to. So what we can do, there's a JavaScript built-in function called from the number class, I believe, called isFinite. Okay, the global isFinite function determines when the passed value is a finite number. So here we can see 0 returns true. This returns true. A string returns. Oh, I see. True would have been false with the more robust number dot is finite. Apparently there's a difference. So this is the one I meant. Number dot is finite. Checks the type of number. Oh, I see. Okay, so it checks that the given value is of this type number. Okay, so this object here. So I'm not a JavaScript expert. I referred to it as a class before, but if this is referred to as an object, then I stand corrected. So we're going to want to use this number dot is finite, and that way strings are not determined, and we get false here, but true for numbers. So the way we're going to want to write this out is we can do it right here. So we're going to want to do refer to our variable which is storing the array, call .filter on it, and then we'll want to do I, and then do an arrow function to return number dot is finite I. So I is as it's going through each of the values in the array, I is that that current value that we're at in kind of our loop for all the elements, and so we are returning for our function, our test function, if this number is, if this value is a number or not, and it'll be false if not and true if so, and then through calling filter, it'll build out an array with only numbers in it. Okay. And then we'll close this off, and then close off the call to tell munch. And then the last step we would want to do is elf.move up, and get our one. So looks like I have my brackets and parentheses mixed up here. So is finite. I did not open this, and then we'll need another one. Yeah, okay. So I forgot my parentheses to open up the call to, or the parameters for .filter. Okay, and I think that should work now. Okay. All right, so we're moving to lollipop 1, then lollipop 0, and then since we're within one square of the munchkin, we're going to ask the question, and then we're going to respond with the answer from filtering with the test is the value a number or not. And that whole filter call is going to return again an array of just numbers from our original array, which contained, as we know, numbers and strings. All right, on to the next one. There are two paths for you to choose. Choosing the lever may take more steps, but might be easier to solve. Okay, so it looks like here we'll go up, right, up, right, up, left, down, and then we can either interact with the munchkin, or we can pull the lever and open the trap, and the munchkin will fall in, and then we won't have to deal with the munchkin. In my initial solve, I did deal with the munchkin, so that's fine. So our restrictions are no more than 15 lines of code and no more than 7 ELF statements. Cool. All right, so what I'm going to do, since this video is getting long, just copy and paste my solution and walk through it here. I use a for loop here to save on some calls to ELF statements, and I'm just moving to the lollipops, having the pathfinding do the trick. Just happened to work just fine for this instance, so that saves me, a good amount of calls to ELF functions. And then I move, after getting all these lollipops, directly to the munchkin, and then let's see here what the munchkin is asking for. So they're returning a JSON object. Okay, he wants to know the name of the key, or the name of the key with the value of lollipop. So JSON is key value pairs. Typically, you would take a JSON object and look up a value from a key, but in this case, it wants us to do basically the opposite of that. So we're going to have to iterate through all the keys within the given JSON and find the value, iterate through all the values and find the associated key. So normally this would be, a very quick lookup. I don't want to get too computer sciencey, but I believe O of 1 if you're doing a lookup from key to value. But now it's going to be O of n because we have to look up value to key, which means we have to go through each of the elements in the JSON object to find out, which key has a value of lollipop. So inefficient, kind of opposite way of doing it, but that's part of the challenge. All right, cool. So for this, we get the JSON from the ELF. We use this object.values call to extract the values of the JSON, and then we do object.keys to get the keys. So now we've got two variables of arrays with objects and keys from the JSON, and then we have a for loop here that goes through the values. So the length of the vals array, and it checks for lollipop, and I don't think we want these double quotes. And then once we do find the in the array of values, once we find lollipop, we know that index correlates to the keys array, and we just submit that answer, and then we move up to our green circle. So let's go ahead and run that. Walk you through it as we're doing it. So for loop is going through, moving to each of the lollipops to save on calls to ELF. And again, this is just some simple pathfinding that the game is doing for us. Next thing we're going to do after that is move to the munchkin. You could start to see why debugging this gets annoying. Okay, so we've won. I think we can try and see our output here. Nope, it doesn't want to give it to me. But we kind of saw here this is example JSON that they would give us. So we extracted the keys and values into their own arrays, went through every value in the values array, found lollipop, and then looked up from that index, that current index in the for loop, the proper key, and then fed that to the munchkin, and that was how you solved that one. Okay, so now we get on to the bonus levels, which get even more ridiculous, but we're going to solve them. Okay. Follow the swirl, being careful not to step on any traps or yeeters. Move 2 has been disabled. Hint, to use loops and an incrementing count to take the exact number of steps. So here you can see our only move at the beginning is to come through here and, well, really we have to pull the lever. We have to successfully pull the lever. We'll be able to move on to that, to pull another lever, to go through here to pull another lever. So a lot of solving lever pulling challenges. And then we, of course, get to deal with the munchkin at the end. So let's see here. Yeah, all these fun levers. Okay, so it looks like this one, we don't even have to get lever. It just says pull lever, and I'll lift the bridge. Okay, this next one, pull lever, and I'll lift the bridge. Pull lever, and I'll lift the bridge. Okay, so looks like most, if not all of these, do not require some sort of a challenge. Okay, cool. And then the munchkin, what about that one? Create a function that will accept one argument. Your created function will be passed a randomized array containing arrays which contain strings and numbers. Your created function must be able to iterate over this randomized array and each of its child arrays and return the total sum of adding all the numbers in all the child arrays. And we saw with filter how we could extract or just determine, if a value is a number or not. Once you have created this function and are sure it will return the desired sum, pass that function as an argument to the munchkin. If our function works, we'll be able to pass. Okay, so I'm going to copy, paste this in, and walk us through how I managed to solve this. We have some restrictions, no more than 25 lines of code, no more than 10 elf calls. All right, so I determined through a lot of troubleshooting and debugging the exact steps that needed to be taken. And I also determined a sort of essentially the turns that needed to be taken exactly to get to the end. And I realized there was a bit of a pattern out of it. Another trick that I did is create a function called pull, and that reduces the amount of times that you have to pull the lever because we are wrapping this elf.pullLever function call inside of another function called pull. So we can call this as many times as we want, and to the game it only counts as one call to elf.pullLever. So just a little trick to get away or get behind the restriction of 10 elf commands. So here this is basically doing a swirl to get out of this whole mess. And so I recognize that pattern. And so there are basically, you have to move and then pull lever, move, pull lever, move, pull lever, move, pull lever. And so I recognize that. And I set, in a for loop, I had a basically, index tracker I, and that was being incremented by 8. So here what we're doing is we move down the number indicated by our moves array, and then we pull, okay, I plus 1. So this is we basically have how much we should move by, our lever, 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 and so on. Okay, and we can see that this for loop follows that same pattern. So we're moving a specific direction, pulling a specific lever, moving a specific direction, pulling a specific lever, and we're keeping track of these values that we need to feed these elf calls, inside of this array. Okay, and this is all to cut down on the amount of calls we make regarding elf functions. So we finally get out of this swirl, and then we move up, and we move to the lollipop, and at this point we need to tell the munchkin our function, and if that passes a test, then we pass around. So this function that I built is nested for loops. So we have an array of arrays. We need to find out those numbers, and we need to basically add them up. Must be able to iterate over this randomized array in each of its child arrays and return the total sum of adding up all the numbers in all the child arrays. So we have a nested for loop for that reason. So basically we start by going through each of the subarrays, and for each subarray, we're determining if every value in that array is a number. If it is, then we add that subarray value to a total number tracker var total, and we just keep repeating, going through for each of the subarrays, going through each value in that array, adding to total if it's a number. And once we get to the end of the array, we go to the next subarray, and we keep repeating that for all the subarrays, and then we return that total number. And we're just providing the name of the function as our answer to the munchkin. That's all it's asking for. And then finally, if that passes, we move up and we get out. So we'll go ahead and run it. This is a bit quick, but just remember, when we're pulling these levers, we're not having to solve anything. It's just we're making that pull lever call. And again, we're using this kind of funky like moves tracker where it's keeping track of the move we're making and then the lever we're pulling. And again, this is all just to cut down on how many calls we're making to elf pull lever, or just elf calls in general. So we win. Our for loop hack worked. Our function for the munchkin worked, and we win. All right, so I believe this is the last level. Yeah, for loop finale. All right. So here, I didn't actually think about that. There's actually multiple ways to solve this. That's cool. Interesting. Yeah. I mean, when I first went through this, I picked one way and it just happened to work. But so let's see. Are these levers the same thing as before where it's not? Nope. Okay, so these levers are actually asking us to do stuff. Sum up all the values. Yeah. Okay. Okay, so we're gonna have to make a get lever calls for all these. All right, so go ahead and paste in my solution to this. Oops. Again, I use this kind of var moves tracker array, and again use the pull hack where I created a function that calls elf.pull lever. Okay, so we're doing the same thing basically as the last one with that for loop and that lever tracker. And then at the end, we need to provide a different function now that does different things. So your creative function will be passed a randomized array containing JSON objects as its one argument. Your creative function must be able to iterate over this randomized array of JSON objects and return the string name of the key with the string value of lollipop. Okay, so anywhere in here, there could be a value of lollipop, and we need to find that value and return its key. So we have to iterate through each of these objects until we find it. So for this, I did a for loop for each of those sub JSON objects, and just went through and oh yes, okay. So I did I extracted the values from that JSON object, and then I used the index of call. So basically, if a JSON object has a certain value, it will return a index that is greater than -1. So like, it's at the index 0 of the array, or the JSON object, or it's at 1 or 2. Now, if it does not exist in that object, it returns -1. So we do a check here. If that index is greater than -1, then we know we have found the key for that, and then we return that key. So object.keys, extract all the keys for this at the index. So then we'll get the key. I don't want to say key value. We'll get the key essentially, and that's what gets returned. So we feed that into tell munch, just the function name, and that'll solve the munchkin challenge. Okay. So if we run that, we see that this initial lever sum up all the values of elf.get lever for the lever you are on and intend to pull, and for all previous levers. So we have to get this number that's returned by the lever, and we have to add it up with all the previous numbers from the levers that have already been pulled. You can see we solved the challenge. So we pull lever 0. We don't have to add anything to that, just return the value that we got from that lever, because we haven't pulled anything before that. Once we get to lever 1, though, we have to add the value that we submitted to lever 0 plus the value of for lever 1 that we received from get lever 1, and then we need to return that value. So we need to keep a variable, high-level variable that keeps track of the previous submissions. Here you can see num0 plus num1. Okay. So to do that, I defined a variable total result, and then in pull, I simply did a plus equals. So that's basically the same as equals total result plus elf.get lever. And then just kept track of total result, and that's what I would feed into pull lever. And really that's it. So I know this is a overly simplified explanation, but we're already running on 48 minutes. So that was a long one. That was a long one. If something didn't make sense, let me know in the comments. I'll do my best to help answer. If I breezed over something that didn't make sense, I can definitely take more time to explain it. So just let me know, and we'll catch you in the next video.